So double checked locking. Double checked locking. I will begin with the example, and only by the example you will understand why it is called the double checked blocking. So let us consider there is a class and which has the requirement that it can have only one object in the system. So how are you going to implement that class? Let's say there is a class H and it has a static member. Okay, and somehow you want to ensure that only one instance of single class, this is Java example, only one instance of single class happens in your system, and that instance is accessed by using this function getSingle. So what should be the approach here? Because the S is null, so one has to check if S is equal to null, then create new object, else okay, no else portion here, just return S. Okay, now this function is perfect if your system is single threaded. If there is only one line of execution, only one thread in your system, then this function works perfect because only one thread will call getSingle, and in the getSingle it will check if the S is equal to null, that is whether the instance has already been created. If it is not created, then create the single instance, assign that value to S, and finally return S. If it has been called once more, then S will not be null, and so it will directly return S. So this function will ensure that only one single instance of S is created. Only one instance of single is created by the system. So this is perfect for a single threaded system. But what will happen if it is a multi-threaded system, which is normally the case? So if it is a multi-threaded system, then what it means is this function getSingle can be called by many threads at any point of time. So suppose that thread 1 calls this function and the execution is right here, S equal to null, and another thread comes up that also calls this function and again the execution is right here. So both of them will think that S is equal to null is right, and both of them will try to execute this function simultaneously. So two objects of single has been created in the system, which is not the requirement, so it will fail this requirement for the multi-threaded system. So what we have to do, we have to put a locking in place. So what we can do in a very simple fashion is put a synchronize here. Okay, so if you put synchronized over here, this is a Java keyword for making this thing thread safe. So only one thread can enter into this method. So one thread is in the executing this method, the other thread will wait outside, and only after the execution of first thread the single class has been created. So when the thread 2 tries to evaluate this condition, it gets false, and it returns the same object which was created by thread 1. So with the multi-threaded system, we can have the same routine. We can have same routine executed using the synchronized keyword. Now, the problem with this approach is the inefficiency. Now you will ask me, where does the inefficiency comes here into picture? Because this get single function is creating the object only once and reading it several times. Okay, so let's suppose in the life of the system this is created only once but read at least 1 lakh times in the system. Now for these many times, even though it is not required, but this lock is getting called. So if two threads are trying to read this particular get this particular object, then also they have to wait for the other function, and in this way this becomes highly inefficient system. And when the synchronized block is used for any method in Java, it reduces the performance of the system by 100 times. So this is not very efficient solution here. So what you can do, how you can improve the system? So for improving this, what you what you can do is, let us rewrite the code again. So this is a class, helper class here, and we have static single, Now here we can check the s equal to null without the lock. Okay, so if s is equal to null, then do the synchronization. And in the synchronization, again check if s is equal to null. And then create the new object. Okay, now you will ask me, what is the purpose of this thing? See, with the first check, now we know that this get instance function is going to be called several times by the system only to get the instance of that particular object. So if the first time we check that if s is equal to null without the synchronization, without any locking, then our read operations are taken care of, because n number of times, because 1000 times we are going to only read the object. So for those 1000 cases, it will simply return s without acquiring any lock. So this has become an efficient read operation. Now we have to take care of the first time when the object is created, and during that time the synchronization is required. So when this get instance is called first time, at that point of time we have to make it safe for the multi-threading. So when s is equal to null, so it is the initialization phase. So we have to synchronize this for the entire object. Now this block is basically synchronized. So let's suppose two threads are trying to call this function at the same point of time. So the first thread evaluates s equal to null, second thread evaluates s equal to null. Both get it null and they come here. In the synchronized block, one of the thread will get in the block, the other thread will be kept waiting. So the thread that gets in the block will have to create the new singleton object and exit. And the thread that was waiting for this synchronization to be released, it will again enter this block. Now here he is supposed to check s equal to null again, because during this time, during the synchronization, the other thread might have created this object. So it has to do this checking once again, and after the checking it has to create the single object. If it is already created, then it has to simply come out of the synchronized block and simply return the s. Now here you see this checking is done twice. Once, first time this check was to ensure that the read operations happen efficiently, and the second time when this check is done, it is to basically ensure that the synchronization happens properly. So this is for the safety during creation. So likewise two times this checking happens, so that's why this pattern is called doubly checklist. So now you understood why I deferred the definition till the end. So typically this is a case wherein this design patterns becomes applicable for the case when there is a singleton class that has to be initialized using lazy initialization plus lazy initialization. So like the example that we discussed right now, there was a singleton class. Now what is a singleton class? Singleton class is basically a structural design pattern that we'll cover in another lecture. That basically means that only one instance of that particular class exists in your system. For example, let us suppose your system has a logging management a logger function. Now that logging functionality has to be initialized only once. Only one instance is required for that particular logging mechanism. Not multiple instances are required. Similarly, the configuration. There is a part, your system must be having a configuration file or configuration table in the database, and there is only only one object required for this particular configuration, because you do not want every time the object to initialize and go and read the file and go and read the database. So only one instance of the object is required. Likewise, other resource-oriented classes are there in the system. Like if your system supports only one printer, then only one printer object is required in your system. So that is for the singleton pattern. So there are several use cases for the singleton pattern. I will not go deep into that. But here it is worthwhile to mention that the singleton pattern has only one instance. That is the requirement. And this one instance can be initialized at the beginning of the service when the service comes up. But it may not be very efficient to do this initialization at the beginning of the service, because let us suppose your system has only one printer, and when the system comes up you initialize that printer, and for no reason you get connected to the printer always. So that is not very efficient way. The efficient way is when the printer is used by your system and the first time it is used, that time you initialize the connection to the printer. So this kind of late initialization is called lazy initialization. Lazy initialization is basically initialize when you are going to use that system. So when these two requirements combined, we have to implement the double checked locking. Okay, and that's exactly we implemented earlier. Okay, so this is one of the very typical use case. There can be other cases also wherein the resource is created only once and later on read by several threads at a time. So there also you can employ this double checked locking.